Hello everyone! Today we will be covering the very last topic in this course, which is on managing and analyzing geodata using GIS. So GIS stands for Geographic Information System, which is a system that we can use to analyze and visualize geospatial data. In this course, we will be using QGIS, which is an open source GIS software. So let's take a look at the modules. In this part of the module, you will learn the different sources of input data and the different GIS data types. You will also get to create a new QGIS project and use the different tools in QGIS. You'll learn how to change the coordinate reference systems for the different layers in QGIS and also changing symbology to better visualize your data. You can also learn how to use attribute tables to better understand your data or to make selections from your data. And finally, once you're done analyzing and visualizing your data, you will learn to create a map as the final product of your analysis in QGIS. So there are 5 parts to this module, and the first part is just on QGIS installation. So if you go to this page, you will see that there are options available for Windows and Mac, and you will have to select between 32-bit and 64-bit. We've already explained here how you can find those information in your computer. There are also videos here that you can watch to see the step-by-step tutorial to install QGIS on your computer. For this course, you will need to download the long-term release version, which is the more stable version of QGIS. And the latest version is version 3.16. If you have any trouble installing QGIS, we would recommend that you do not spend too much time trying to install it on your computer because this software is also available on the remote desktop in UG Lab. So it would be better for you to access the remote desktop from UG Lab instead. Part 2 to 5 in this module will cover the different lesson objectives that we have already talked about before. And at the end of each module, you will find a very short quiz that will help you practice using QGIS. Now we will go through the GIS data layer slides. And you can follow along the demonstration in some parts of this lecture by using this folder, the V1 Start New Project folder. So if you go to that folder, you will see this Layers and QGIS folder, and you will have to click on the QGIS folder and select My New Project to open the QGIS project that we use as an example in this lecture video.
So I already mentioned that what is GIS stands for. That means we have the information of coordinates, information of the location, and then we actually bring in the information we have with the geospatial information in it, and then analyze the data. So we could have spatial information of the attributes, or we could have non-spatial information of the attributes, and we bring those two and then visualize them into our map in a software, and then we analyze them. So that means we incorporate databases that we could have multiple database or we could have one database. In that database we also have this spatial information, and then we actually integrate them into our system. So in the database, what we basically do is that when we bring the data in, we basically ask what versus where. Also, we want to we need to specify when it happened, because these are important questions. So that means in a map, we need to know what we want to show in the map and what place where in the art we actually want to show, and when, because if we have information and the map, let's say of Vancouver 100 years ago, and then now I'm creating a map, now I would like to show the land use changes in Vancouver, and then if I show the map from 100 years ago, but if I am showing what's happening right now, that's actually backdated data set, backdated map we have. So that means we need to add in our map when we actually got the data. So that means when the time is really important. So we basically have collection of information, and then we show them, we visualize them in a map, and we try to answer some objectives. So we need to identify what is our objective, and then we can visualize, or we can format, and we can actually analyze our data, then add the map elements. So what can be done with GIS? So you can see we have a map of a place, but then again you can see we have maybe we have city information in there. So in that map, basically we add the data. Let's say we would like to know the population density in each of those areas. So we have the base map, then we collect the information if it is available, and then in each of those areas we assign an ID and we assign the information we have. So let's say in each of those areas, what's the population density, we have that information, and then we add this table in our map, and then based on the information we have, the population density, let's say if it is a lighter color, the population density is really low, the population is really dense in some other areas where we have the darker colors. So that means we are providing information to people based on the color, we are showing all those information. So in another example, I can show it better. You can see also I gave you the where I got this map from. So we have a map from Vancouver Island, and in Vancouver Island from 1952 versus 2012. So you can see this one is from 1952, this one is from 2012. So we are basically trying to show what is the changes. The changes means what changes we would like to show over time. So that means 1952 versus 2012. In these years, what are the land use changes over time? So you can see we have lots of areas where we had ancient forest, but then again over time in these how many years, about 60 years, what are the changes occurred. So that means on this map, whenever we are showing it, we are trying to show the changes in those ancient forest over time, and then maybe it's actually came from a project from ministry, and they would like to take a decision or make a policy based on the changes. So that means at a glance we can see the changes over time, and then we don't have the data file in here, but then again when we were creating this map, we had the data, and then we visualize them and we show the differences over time. So in GIS technologies, we have two sources of input data. So basically maybe you use those, but we don't know. Actually these days in our car, in our cell phone, everywhere we are using GPS. So GPS is mostly global positioning system. So using that GPS, we try to identify the location on Earth. So that means we try to find what's the latitude and longitude, what's the coordinates. That means, let's say I'm going from a location A to location B, and then location A, what's the coordinates, lat long, and then in location B, what's the coordinates, then we can find what's the distance between them. So we are using GPS every day, and that's a source of input data. That's we use in GIS a lot. And another sources of input data is remote sensing. So using satellite or aircraft, it's actually captured the information of Earth. And let's say we can say the hydrology. In hydrology, massive remote sensing data is used. Sometimes we have the flood forecasting or reservoirs or irrigation scheduling. So all those can be all those information can be stored, we can get it from using the remote sensing data. So remote sensing data can be integrated with the with GIS, that means geographic information system. So what we can find is the forest inventory data. Let's say we have the remote sensing data of a forest, and then we can get the information of stands using these techniques. And then we can have broad area monitoring of forest health or natural disturbances. And then we can assess forest structure in support of sustainable forest management. So you can take a look at this file if you want to know more. So in GIS we have various components. Let's say the data is the most important part. It takes about 80%, not exactly 80% all the time, but most of the 80% time is spent on GIS project. That means acquiring all the database and then preparing the data. Without data we cannot do anything. And people, obviously the personnel that are going to collect the data and then create the hardware and then software. So for hardware is the physical elements that make up a computer system. For the software we used to use ArcMap, but then again in this course this term we are going to use QGIS. So the procedure, we will be following some procedures, and then sometimes we build a model so that it's actually reproducible. We can get the reproducible results. So in GIS we have the attributes. That means we can have a table of information. So let's say in our data sets, let's say this is a data file. We gave you this data file. So in this data file, when I bring in the data, that means on each of those data, right now I'm showing you the vector data. If I open the data file, if I open the attribute table, that means ID is an attribute, and then poblado, that means the name, this is also an attribute. So we have some attribute information. Also we have if I open the roads, then we can see which province it belongs to, and then which classes. All of those information are there. So that means we have attribute information, and then in each of those rows we have each of the roads information. Let's say if I only like to show the roads, so you can see I only kept roads layer. See, if I have the roads layer and if I select some of them, so you can see I selected some of them, so that means those roads, those 7 roads are highlighted in here. So or we can see that if I am interested, I can identify each of them and I can find the information of that road. So that means in each of those rows we have, just like Excel, we have information of observation. So this is in each row we have the observation. That means each of those roads are listed here, and then we provided an ID to identify them. So in attribute table we could have spatial information, or we could have non-spatial information as well. So that means we could have information of trees, but then again we can have information of tree height, age, DBH, and vegetation type. Those are not spatial information. That means these are non-spatial information, but maybe they are in a forest. If we have many types of trees in a forest, where they are located, then if we have information of location of each tree or each planting site, then it's actually spatial information. So we actually mixture spatial information with non-spatial information. So you can say, I gave you an example. Let's say in a city we have information in a table wherever we have the fire hydrant, and whenever the firefighters hear about any incident, then they go to the place. But if they have an app where they have information of all those fire hydrant, they can locate easily. So if we need to add, maybe from the city corporation, they would like to add a new fire hydrant and where it should be, so they can see where there is a gap, there can be added a fire hydrant. So that means where we have those fire hydrant, we showed them using a dot. So in GIS we have two types of data. Previously I shown you 2 sources of input data, raster and GIS and GPS, but this time we have types of data in GIS. That means raster data and vector data. So raster data is basically, we have, just like in Excel, if we can think of Excel, we have, like in a cell we have information. That means each cell is a grid, and in that grid we have information of variable. Let's say we are defining the world as a regular set of cells. That means we have x-axis, we have y-axis, and each of those cells represent a given area on the ground. So that means we are actually showing our spatial information on a grid system. And then you can see we actually shown the water. You can see in each of those cells we try to show that wherever we have water, that means it's actually gave a blue color. That means for those watershed we actually have some values in there. Let's show you in a map. So annual precipitation. So you can see annual precipitation, we have values. That means if annual precipitation, that means is higher, that means it's a darker blue color. If it is lower, it's a that means the lighter shade means the annual precipitation is really low. If I open that, so let's zoom to there. So you can see, we can see the map, but then again precipitation is higher, you can see wherever we have the, I think the rivers we can show, and then we can show the roads. So you can see wherever we have the darker colors, that means we have precipitation is really high. So let's see, let's make it larger. So you can see each of those cells are actually colored based on the value behind it. That means if I click on each of those grid, so you will see that it's actually changing the value. That means if it is darker, the annual precipitation is higher, 145. If it is really light, annual precipitation is low. So let's say I would like to see wherever we have really light color. Okay, so we can see we have lighter color in here. Let's identify them. You can see it's, if it is darker, then it's actually increasing. So that's how the raster data works. So it's most like a picture we have. So in those picture we have cells, and in those cells we have the values. So that means for precipitation we have information on this picture and we can identify them. So it's a little bit different than the other data types. So the other data type is vector data. In vector data, information is stored in points, lines, or polygons. So let's say in the fire hydrant, wherever we have the fire hydrant, we showed using these dots. So you can see we have these dots. That means if I am talking about vector data, we basically have points, lines, and polygons. If we are talking about lines, that means you can see we have street. Those streets are actually lines. And then if we have polygons, so let's say polygons, let's show you in here. Okay, so you can see in this map we have a map of South America, and then each of the country is actually separated by border. So that means if I identify one of these countries, so it says that it's actually Colombia, and then you can see it's actually Venezuela. So each of those countries are a polygon. That means they are separated by lines using these borders. So whenever we have the let's say we have roads, so if we have roads, they you can see they are actually shown in here. And then if you make it larger and identify them, so that means each of those roads we have, if I go to the table, you can see, so that means each of those roads are separated and we provided information of those roads. If we are talking about points, so you will see that we have information of points. Let's say in Ecuador, the land use settlements, we have information of those in points. So that means we are showing them in really small points, but if you want, you can make it larger, the font size. So you can say I just clicked on it and say the size should be larger. So you can see. So that means the information is on points, and it could be if we have river information, if we have roads information, you can see roads are in this black color dash, and then the rivers are in blue color. So that means we have information in based on what type of attribute it is, or what type of data it is. If it is a roads, then it should be lines. If it is discrete, let's say information of some city, let's say where is the recreation center, we can add it as a point. And if we are interested about the site, that means the area, then we have to use a polygon, what I showed you in the cities in South America. So whenever we use zoom to layer, so you can see we have polygons. That means they are actually connection of many lines. So let's go back to our slide. So that's what I showed you. If it's actually in a vector format, then we show them using the dots, any symbol you can use. But whenever we are showing them in the raster data, it should be in a cell. If we are talking about lines, then you can see it's an order of set of coordinates. That means if we have coordinates in point A, in point B, we can connect them and make a line. And the middle of the point is called vertices in the lines. So that means if we have roads, the middle of those points are called the vertices. It also called the lines also called arcs. So the polygons I just showed you. So in here we shown the elevation. That means we are showing it in interval. We show that if the color is lighter, then it's actually lower elevation range, and if it is darker, you can see in these sides we have really a high elevation. At a glance, points, lines and polygons is showing the data file, how it looks like. So you can also check out our data file. So you will see that in our data file, whenever we have point information, if I go to the table, so you can see we have points information, and I go to the roads information, you will see how it's look like. That means we have the information of each of those lines, and then when it started, when it ended, and then what the points and polygons. You can see we have the countries in South America, and then we listed them. I already showed you the vector layers in our data and raster layer in our data. So let's say, no, I didn't show you the raster data. I just showed you the annual precipitation raster data for annual precipitation. So that means you can see in cells, in each of those cells we actually have the colors. So basically in you see that in QGIS, I try to show you what are the where are those elements are. So let's say in QGIS, on top of our area, so let's say we have the raster data, zoom to layer. So that means in our QGIS we have the toolbar at first, and then in those toolbar we use all those tools. Let's say well, how I was showing you, if I want to zoom in, I can use that. So I can zoom in, and zoom out, I can use that, zoom out. Or you can just use your mouse so that you can actually see where we are at. And if you want to go back to the previous layer, that means zoom to layer, it will go back to the original size. And then if anytime you want to identify, then you can use this identify feature. Also over here you can see we have the, wherever we have the data file, where it's located in my desktop, it shows in here. And if you want to locate anything, any of your folder, you can just right click and then add the directory. That means wherever we have the data, you can just select and then add that, you will see that showing up here. And then on this side we have the table of contents. That means what we are showing on the map or showing or not. If it is selected, that means we are showing on the map. If it is deselected, we are not showing. So if you need to show any layer, let's say I would like to show the equator settlements points, then you can see which one should go up, which one should go below. You need to think about it. If you want to show the settlement points, and if it is underneath your annual precipitation, you cannot show, it's not actually showing up. And then you need to think about which layer should be on top of each other. So maybe the size of these points are really big, then you have to make some adjustment for those points. Let's make it size 2. Yeah, so you can see now it's way better. So on this side of the software, what we have is the toolbar. If you want, you can just close them, or if you want, you can bring them back from here. So you can see the processing and then toolbox. So you can see we are showing the information. We can find all the geoprocessing tools we will be using. So basically we'll be using the vector geometry from this vector geometry tool. And for the geoprocessing, for the raster data versus the vector data, we will be using these tools, the geoprocessing. And anytime you want to find any items, let's say clip, you can just type and then use it. And description of each of those tools are actually provided on this form. Okay, and then try to save them whenever you are working on it. Saving is important. And anytime you can change the symbology. So the coordinates, you can see I shown you in here. So coordinates wherever we are right now, it actually shows in coordinates, so you can see. And scale of the map, you can see I made it larger. If I make it really small, then you can see the ratio is changing. That means on the earth and then versus on this map, what's the ratio of them. Okay, so that's what we call the map area. And then we have the coordinates, we have the data layers, what you want to show on the map, or you can select them, the browser directories and toolbox. And so I will be talking more about toolbox while I will be showing you geoprocessing tools. So using the toolbox, we can analyze our data. And then we can actually focus on or identify the objective areas that we are interested to analyze. So using the toolbox, using the tools that we have in toolbox, we can actually use those and analyze our data. So these are just example of some maps. This is the map you will be working on in the QGIS exercises. So that's it for these GIS data layers. Thank you.